Alright, I'm back on the Hercules engine finally. I've got my new rings for the piston and a wrist pin bushing, I was waiting on those to come in. I had ordered those from Hit and Miss Enterprises in Ohio. Like I said, I got my rings. They're straight cut rings. I believe the originals were cut in an angle, but these will work just fine. They're nice. They're cast iron rings. Nice. They're really plain. Just looking it over, you can see that they fit a little bit loose in the ring grooves, and that's about 9 thousandths worth of gap in the top. Let's see, what's that? Oh, sorry, 8 thousandths. About 8 thousandths in the top, in the middle, and a little bit less in the lower. It's pretty tight in there. So there's some play. Too much, but I'm not going to worry about repairing it. I mean, that would either mean making shims for the rings or doing some serious work on the piston, but this engine's not really worth that kind of work. Plus, I think it'll run just fine. So got that. I made myself a new wrist pin. It's actually stainless. It's pretty hard for stainless. I don't know what the spec on it is. I bought a 6-foot bar of this to make some axles, just because it was kind of like a clear out of this one place, and I just picked it up. But yeah, I think it should wear pretty long. I think it'll get a good service life out of that. And here's the new bushing. Let's see, brass, bronze, not sure what you call it, but here's the old one. I'll show you the old wrist pin and the old bushing. This is the original wrist pin. You can see you got some pitting there, right in the bearing surface too. This is the original bushing. It's a little snug because when I pressed it out, I kind of peened it in a little bit. But you can see there was a bit of play in there. You know, seeing worse, of course, but just figured it's not that big a deal to replace it, and I already had the material for the wrist pin, so I'll just get a bushing. But yeah, when I got the bushing, it was just a round cylinder pretty much. I had to, I mean, it was drilled through, of course, but I cut the oil notch in there just with a file, and I drilled the oil hole. Of course, once it was already in the wrist pin, I did that, or in the connecting rod, I did that. And once I fit it into the connecting rod, it shrank a hair, and I had to ream it out so that the new wrist pin would fit very snug. But it does. It fits quite well. Really, almost nothing at all. It fits quite well. So I'm pleased with that. So we'll just assemble that together now. See, that's that bolt right there is just a set screw. That's why there's that hole in the wrist pin there. So, let's see. I believe the set screw, if you're looking at the rear of the engine, goes on the right. And the oil hole obviously has to be up. So, let's see. Slide it through. Now we'll have to see. I don't know. I might need some shims in there. There might be a little bit of slop in here. I mean, side to side. Oh, and there is a lot, actually. So, now, I'm not going to take all of that up, but I will take some of it, just because there's always a hair, a little bit of misalignment. You want to leave a little bit of play. I have these shims here. Let's see, I may have 3 of them. Maybe I'll put 1 on each side, I guess. Do that. Just 1. Fish that other one in there. See, only a little bit of misalignment there. Use a little cotter pin to push that. Too far. There it goes. All right. A little bit better. Like I said, a little bit's good, but not too much. Make sure the hole's gonna line up. This for the set screw. There's the hole right there. Should be right about where we want it. Okay. Okay, and that's that. That's piston. A little bit of side to slide, but that's okay. Still pretty solid. So next we'll install this in the bore. One thing I forgot to mention was about setting the ring end gap before you put the rings on the piston. To do that, you take one of your new rings and you push it in the bore. You squeeze it together and you put it in the bore by hand without it being on the piston. Then you use the piston and you push it back in the bore about midway in the stroke, and you measure the gap that's left behind. If it's too close, when it heats up, the ring will bind because it will expand, and if it's obviously too large, you'll lose compression or you'll allow oil to pass up into the combustion chamber. I did gap these. Of course, I didn't really need to. I put them in the bore, and the gap was pretty larger than it should be. The rule of thumb for these old engines, at least these big slow speed flywheel engines, is about 4/1000 gap per inch of bore. So this is a 3 5/8 bore engine, so you can figure that out, whatever it would be. I figured it out before, but I forget the exact number now. And that's what your gap should be. These were at least twice that, which is unfortunate, but given the wear and, like I said, the value of the engine, not really worth putting a sleeve in it and doing all kinds of machine work. I think it'll run just fine. I'll mention that I said I wanted to be able to do a compression test. I actually made this little adapter here. So 1/2" NPT thread, and then I drilled it and I tapped it 14mm by 1 1/4. So that's just a normal spark plug thread. What my compression tester is actually, So I'll be able to actually test compression for the first time on one of these engines. I have never done so. Alright, I'm ready to install the piston in the bore. I've already got the flywheel sitting in the bearings. They're just sitting there right now. Always amazes me how nice how nice they'll spin, just with a little bit of oil on that babbitt, just how little friction there is. So yeah, I have them on there just so when I install the connecting rod, I can slide it in and I won't have to worry about holding it out of the way simultaneously while putting the flywheels in. Don't have to worry about damaging anything. So go ahead and start with that. So first we'll mention just how you stagger your ring gaps when you're installing your piston. 3 rings, I align them just like in a triangle. 1 gap straight up, right there. 1 gap to the lower left, and 1 to the lower right. Easy enough to do. Make sure I'm in the shot here. 1, 2, where my thumb and my pointer finger are, and 1 up top. Set that aside without messing them up. And just make sure the board's nice and clean, and just lubricate it pretty well. Oil, because whatever oil you're putting in now is going to be with the engine first time you start it. It's where it gets messy. Rub it all around. Do the same on the rings. Make sure they didn't move. 2, 3. Drop that on the ground. Spin them all around. See. It helps to have all the ring gaps lined vertically when you're doing this, so you can kind of fill them with oil. And you lift the rings up from the bottom and kind of let the oil run down underneath the rings. I'll do this twice. And of course you lube up the wrist pin too. So they're pretty well soaked with oil there. I'll line them back up again in the triangle. One, 2, 3. Just lubricate the rest of the piston a little bit. Slipper in. And just bump it in. And it goes. A little bit of a messy job, lubricate the cylinder and everything. Now if you do it barehanded, it is. So that's it. We're in the bore. I'm going to put the end cap on and just run up and down the board and see how it sounds. Alright, I got the main bearing caps on. They're just snug. They're not shimmed or anything. They're just sitting on there. And I have the connecting rod main, the connecting rod cap on. Again, it's not shimmed or anything. There's a gap there. It's just kind of snugged up a little bit. It's making a little bit of noise, but it should snug up once I shim it and everything properly. Here you can listen. You can hear the rings rubbing up against the cylinder yet. Definitely got to wear in a little bit. I don't know if you got a good look at it, but the surface of the rings, where the surface that contacts the bore, it's a little rough when you first get the rings, which I think is nice. I think it helps to just almost act as a grinding compound, almost like lapping a valve in. It kind of helps the rings seat in the cylinder or get mated to the cylinder. So that's that. Next video, I'll put the head on, and I'll put the magneto bracket on, which is also the spark plug, has the threads for the spark plug in it, and I'll do a compression test. Of course, it'll be just, it's not broken in yet, of course, so we'll just see what kind of compression it makes right after being installed. I'm pretty interested to see what it would be. Let's see. Don't really see a whole lot of movement in the piston. There's a bit though. Let's see. Let's see. It's actually not too bad. One thing I am surprised at is how high the piston comes up in the bore. I didn't really notice this at first, but if you look through here, you can actually see the top ring, and about 2/3 of the ring is exposed. I didn't think I would see that. I don't really recall seeing that or noting that on any of the other Hercules engines I've worked on. Oh well. Seems like you'd really get some carbon buildup in that first ring there. Means that's right at top dead center is when it's gonna fire, but oh well, that's the design, I guess. Yeah, so anyway, next video I'll put the head on.